These are notes from section 6.5, which is on solving radical equations. When we solve a radical equation, our goal is to get the root by itself, whether it's a square root or a cube root. And then we are going to cancel out that root by raising both sides to whichever exponent is going to cancel. So we can cancel a square root by squaring both sides, a cube root by cubing both sides. If it's a fifth root, raise both sides to the fifth power, and so on. It is important that you check every solution. When we square both sides, it is certainly possible that you could get extraneous solutions. A very basic example of where those extraneous solutions may come from. If I start with a pretty basic equation, x equals 3, x is only equal to 3. That is the only solution that makes this true, is if x is 3. If I square both sides, I get x squared equals 9. Well, now I have two solutions. My new equation has two solutions, x equals 3 or x equals -3 are both solutions to my new equation, even though x equals -3 doesn't work in the equation I started with. So anytime you raise both sides to an even exponent, it's possible that you may have extraneous solutions. So it's important to check every solution that you have. Pretty basic example for the first one here. I don't know why we're starting with example 3, but we'll go with it. It asks us to solve 2 plus the square root of 3x minus 2 is equal to 6. So we want to start by getting the root by itself. We can do that by subtracting 2 from both sides, giving us square root of 3x minus 2 is equal to 4. We have the root by itself, so now we want to cancel that root out. It's a square root. We can cancel that by squaring both sides, giving me 3x minus 2 is equal to 16. And then we should very easily be able to solve for x. X equals 6. Again, before you circle it, move on, it is important to check your solution. So plugging 6 in for x, I get 3 times 6 is 18, minus 2 is 16. Square root is 4. 2 plus 4 does indeed give me 6. X equals 6 is correct. Example 2 or 4 asks us to solve, I don't know why that's an inequality, that should be an equal sign. 5 minus 2 times the cube root of 8 minus 2x is equal to 15. First thing we need to do is get the cube root by itself. Lots of students are tempted to start with 5 minus 2 and write that as 3 times the cube root. These are not like terms. I cannot combine that 5 minus 2. Instead, we want to start by subtracting 5 from both sides. Get -2 times the cube root of 8 minus 2x equals 10. Now we can divide both sides by -2. To undo the cube root, we're going to cube both sides. Cube root and cubed cancel, giving me 8 minus 2x equals -125. Subtract 8. -2x is -133. So x is 133 over 2. Again, check your solution, plugging that in. So times 2 gives me 133. 8 minus 133 is -125. Cube root is -5. Times -2 is -10. I'm sorry, positive 10. -2 times -5 is positive 10, so I get 5 plus 10, which is indeed 15. So first couple examples are relatively basic ones. Get the root by itself, cancel out the root by raising both sides to the exponent. Don't forget to check your solutions. Next two examples are a little bit different. Example 5 asks us to solve 2 times the quantity x minus 2 to the 2/3 power is equal to 50. First step, divide both sides by 2. X minus 2 to the 2/3 is equal to 25. From there, this rational exponent, the 2/3, we're going to split that up in the same way we did in section 6.4. I'm going to write this as x minus 2 to the 1/3 and then squared. X minus 2 to the 1/3 power and then squared. Notice power of a power, that's the same thing as 1/3 times 2, which is 2/3. I need to cancel out that squared. We cancel a squared by taking the square root of both sides. So I get x minus 2 to the 1/3. The square root canceled with the squared. Anytime I take the square root of both sides, or any even root of both sides, I need to include a plus or minus. Basically, if I had x squared equals 25 and I square rooted both sides, x could be 5 or x could be negative 5. X squared equals 25 has two solutions, x equals plus or minus 5. So if you take the even root of both sides, you're going to need that plus or minus. As we'll talk about in the next example, if it's an odd root, if you take the cube root, you do not include the plus or minus. 1/3 power is the same thing as cube root. We can cancel a cube root by cubing both sides. I get x minus 2 equals 5 cubed is 125. Negative 5 cubed is negative 125. And add 2 to both sides. (125) plus 2 is 127. Negative 125 plus 2 is negative 123. Again, you do want to check your solutions. Subtracting 2 gives me 125. 125 to the 2/3 would be 5 squared. 25 times 2 gives me 50. That checks. This one also checks. Negative 123 minus 2 is negative 125. To the 1/3 is negative 5. Squared is 25 times 2. They do both indeed check. Example 6, very similar problem, but instead of the 2/3 power, it's the 3/2 power. Add 8 to both sides. From there, we divide both sides by 7. 189 divided by 7 gives me 27. Again, once I get the quantity by itself here, I'm going to split that up into 2x plus 8 to the 1/2 and then cubed. So that when I undo things, I can then undo them from the outside in. So to undo a cube, we're going to cube root both sides. I get 2x plus 8 to the 1/2 equals negative 3. Now I square both sides. (2x plus 8 equals 9. Notice here when I took the cube root of both sides as an odd root, I do not include a plus or minus there. Subtract 8 and divide both sides by 2. X equals 1/2. We do want to check our solution. 2 times 1/2 is 1, plus 8 is 9. 9 to the 3/2 square root of 9 is 3 cubed is 27. So we get 27 times 7, 189 minus 8, which is not giving me negative 197. So my solution here did not check. That was the only solution I had. This equation has no solution, no real solution at least. This one actually, there was a step where you might have been able to recognize that there was no solution without actually doing all of the work and getting down to an extraneous solution. Once we were at this step right here, where we had 2x plus 8 to the 1/2 equals negative 3, remember the 1/2 exponent is the same thing as square root. So I have the square root of something equals a negative number. There's no real number that when I take the square root of, I get a negative number. So you could have stopped right there and said that there is no solution at that point. These next couple examples are a little bit different in that they not only have an x under the root, but there is one on the outside of the root as well. We attack them the same way. We're going to start by getting the square root by itself. Subtract 5 from both sides. From there, we cancel out the square root by squaring both sides. X minus 5 squared, you can either write it out twice and FOIL it, or remember the rule for a binomial squared. Either way, you should get x squared minus 10x plus 25. The rule is the first one squared, multiply them together and double it, negative 5 times x. Twice that is negative 10x. Plus the second one squared, negative 5 times negative 5 is 25. If you don't remember the rule, write it out twice and FOIL it, no big deal. We've got a quadratic equation. We solve quadratics by getting them equal to 0. So I'm going to subtract x from both sides and add 3 to both sides. And we solve them by factoring if we can. Numbers that multiply to 28 and add up to negative 11 are minus 4 and minus 7. Set each factor equal to 0 and solve. X equals 4 and x equals 7. As always, we want to check our solutions. Plugging in 4 minus 3 is 1. Square root is still 1. 1 plus 5 gives me 6, which was not what x was equal to. X equals 4 does not check. X equals 7. 7 minus 3 is 4. Square root is 2. 2 plus 5 gives me 7, which is what x is. X equals 7 checks. It's possible they both check. It's possible one of them checks, but one doesn't. It is possible that neither one checks, and we have no solution. One more like this. Wouldn't be a bad idea to pause the video, try this one on your own. Make sure you can do one like this. And then once you think you've got it, you can start the video back up and check your solution. We want to add x to both sides, giving us square root of x plus 7 equals x plus 1. Squaring both sides gives me x plus 7 equals x squared plus 2x plus 1. Again, to square a binomial, we square the first one, we multiply them together, which would be 1x, and then double it, and then square the last one. Get your equation equal to 0. Factor. Solve. Check for extraneous solutions. That'd be square root of 4, so 2 minus -3. 2 plus 3 is not 1. Plugging in 2 gives me 9. Square root of 9 is 3. 3 minus 2 does indeed give me 1. So again, the second one checks, but the first one doesn't. That is section 6.5 on solving radical equations. Reach out with any questions you might have.